소개해 주셔서 감사하고 초대해 주셔서 감사합니다. 어, 약 한 시간 동안 제가 여기 UT에서 하고 있는 연구에 대해서 소개를 드리도록 하겠습니다. 발표는 영어로 진행할 거고요. 나중에 Q&A는 한국어로 해주셔도 괜찮습니다. 네, 그럼 발표 시작하도록 하겠습니다. Okay, so I'm going to talk about how can we build an intelligent agent that can evolve to an evolving world. And I work on language processing, and these days we are really getting impressed with this large-scale language model that we train on diverse text all over Wikipedia, social media, news articles, and all these things. And we are training this really large-scale model that consumes the trillions of tokens, and they basically memorize a lot of facts about the world. So we come with this knowledge-rich models, and we use this for various things. But before going through how we use this, let's think about like what kind of things are actually getting memorized during this large-scale pre-training process. So there has been this study last year. They were looking into when we let this large models to memorize corpus, how much do they actually memorize them? So they did a study of looking at the prefix of sentences that was in the pre-training corpus, and then see whether the model we're gonna generate the continuations of this prefix as is in the pre-training corpus. And in this example, you can see that for the larger variants of the model of 6 billion model, it was generating what was in the pre-training corpus as is. And then the smaller models were getting slightly worse and doesn't really memorize exactly what was there. So this was showing it's an empirical study about how much during this pre-training the model memorizes things. And they also show that the bigger models memorizes more. And if the same sentence has been repeated multiple times during pre-training, then model tends to memorize that fact more. So kind of like both of these graphs kind of make sense. But it really shows that model has really powerful parametric knowledge, meaning that the language model itself knows a lot of facts. And we do use the knowledge from this language model to do a lot of things such as question answering. So I posed this question, who are important figures in Korean culture, and to ChatGPT like a month ago. And then it started generating these sentences. Important figures in Korean culture include King Sejong, Admiral Lee Sun-shin, blah, 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 ending with kimchi. So it seems like the language model knows something about Korean culture. And there has been recent work looking into how can you actually surface the knowledge in the language model into something that's more interpretable to human eyes. So they were kind of rebuilding this kind of knowledge graph by querying the language model, and they were able to reconstruct kind of knowledge graph about the Alan Turing by querying the language models. So we are using this language model for all sorts of tasks nowadays, for question answering, but for all like vision stuff, robotic manipulations, all kinds of things. And we are relying on this rich knowledge that's memorized in the language model. But there are issues when we are relying on this language model to answer our queries. One big issue with it that's shown in prior work is that the models are pretty good at answering things that's getting frequently asked. But if you ask about somewhat rare entities, the model still generates fluent queries, fluent answers, but a lot of facts about the answers that they are generating are now no longer accurate. So here you can see on the right side is popular entities, and you can see the performances are much better. And for rare entities, the performances are significantly worse. So model has issues with this long tail entities. And another thing is because model kind of mixes up the true things about the word and also untrue things about the word. And because models was generating it as is, it's kind of hard to verify the correctness of the information it's generating. So these are kind of known issues. Another issues with answering questions with just relying on LM's knowledge So I asked this question, who won the most recent Grammy Award for Best New Artist? And model replied, Billie Eilish. And it was not a completely incorrect answer. She actually won this award in 2018, but no, if I asked this in 2023, they should not have given me this outdated answer. Similarly, if I ask who is the current Prime Minister of the UK, it says Theresa May, which was true, but not anymore. So they were trying this kind of like model memorize something, and then that knowledge is outdated. So this was February 2023, and things are changing fast. So I tested again a couple months later. And then the ChatGPT, the newest version, is showing slightly better behavior now. I asked who won the most recent Grammy Award for Best New Artist, and then it's now saying, oh, I cannot answer that anymore because my knowledge is outdated and I don't want to give you an outdated answer, basically. So it seems like models are kind of getting better with these behaviors, but actually, if you ask another question that's still temporally dependent, meaning that it's changing over time, but doesn't shout that it's like changing as much as this question, which has most recent, which is kind of simple keywords to figure out whether it's temporally dependent or not, such as researchers at UT Austin in computer sciences. And it gave me a list of 10 famous colleagues of mine. I haven't made the list to that yet. I'm not the most as a young faculty. But when I actually examined the answers carefully, I found that actually 3 of the people who are listed there are no longer at UT for various reasons. They left for companies or moved to other universities and so forth. So the model is having issues with repeating outdated informations. And there has been also like more computational studies about this. The language model's perplexity performances gets worse and worse and worse as the gap between the time when the model was pre-trained and then the test corpus was taken gets longer and longer. And also another recent study was looking into this pre-training data and then this large scale model and how that impacts, and also found that the effect of this temporal pre-training misalignments are stronger for larger models than smaller models. So this is an issue that simply just scaling and training bigger models will not gonna solve for us. And there are multiple types of temporal drift. One is like question distribution itself is changing. Before coronavirus happened in 2019, no one were going to ask about it at that topic in 2014 or something. So the question distribution itself is changing. But more importantly, sometimes the question remains the same, but then the answer distribution is changing. So where were the last Winter Olympic Games held? In our data, annotated question answering data, maybe it was annotated as Sochi because it was annotated 2018. But then the answer is no longer true because things are moving away. And in our previous study, we looked at it and we found that in all 4 QA data sets that we are looking at, 13 to 30% of the questions are have this temporal dependency behaviors. And I think this is pretty important if you think about what kind of questions do you ask frequently. You don't ask questions that doesn't change over and over again. Like you learn the fact and you don't ask it again, but something that changes frequently, you actually ask those questions more frequently. Like, how's the weather today, right? Because that's changing, we ask those a lot. So capturing this kind of temporal distribution shift is important. And there has been approaches to do kind of simple quick fix to augment the language model on ability to look up the more up-to-date information. So it has this parametric knowledge that's memorized during training, but at inference time, we now allow the model to basically look up the Google and then take the documents and then use those to answer the questions. So it's a simple fix. So basically, it's this gap between test query and then the model. You are making the model to be up to date by simply swapping the search corpus to be more recent documents. So this simple fix is called in-context retrieval augmentations. So you have this query or sentence that you would like to finish. You retrieve relevant documents, you concatenate those relevant documents, and then let the language model to answer it. There are some good things about this type of knowledge augmentation to language model. One is that you don't really have to update the language model parameters at all, which means you can use whatever your favorite black box APIs that you want, like GPT-4 from OpenAI or something. But then the issues with this in-context augmentation is now the inference cost increase because you have to concatenate the new document that's been retrieved. And also, when retrieval is not working very well, and if you actually concatenate irrelevant or incorrect documents, then actually your model performances drop compared to not doing these augmentations. So these are kind of two issues with it, but this is kind of one simple way to fix it. And we see kind of this is already in our lives. When you do search, you see the model, this is a Bing search. You ask a question or give a comment, and it's like fetching this document and then answer the questions based on those documents or try to do that and make these citations. But this is still quite new, and there has been a recent study that's looking into if we said that it's from the documents, is it really from the document? So they kind of compared the evidence document that's linked here to the sentences that's generated, and they find that actually the citation precision is somewhat limited. So sometimes they said that this document supports this fact, but it was not true for quite substantial percent of the examples. So there's like still improvements that needs to be made on this kind of retrieval augmentations. And more than that, retrieval augmentation cannot be the sole solutions of trying to update the model's knowledge. So if we prepend the updated documents, would the model output the new answer, forgetting what it has memorized during pre-training? So that was kind of the question that we were trying to answer. And to study this, we have this like a very controlled setting. So we are looking at, in our EMNLP paper last year, we are looking at this settings where we have a question, and then we only look at the questions whether the model got it correct with the parametric knowledge alone that it has memorized. And then you put this additional documents that contains kind of the correct reasoning for answering these questions. And you perturb these documents that you are giving to the model to a new answer. So these documents were all saying that Norway won the most medal for Winter Olympics, but then you swap the entity there so that it's now the model is given the documents, which says that the country which won the most medal is Italy. So the parametric knowledge would still gonna say it's Norway, and then this new document that it's given at inference time, we're gonna say it's Italy. So if the model is gonna be able to completely ignore parametric knowledge and only gonna depend on this document that it's concatenated at inference time, then the model we're gonna say Italy, and if it's not, then it's gonna say Norway. So we did a controlled study with this. So this model was looking at up to 100 passages. So we have the settings of swapping all the 100 passages saying Norway to Italy, and then 50% swap, meaning that we were going to swap half of the answers, and 25% means only 25% of the answer will going to be changed to Italy. And when we looked at the results, we found something interesting. So when we swapped 100% to Italy, the model still didn't say give the new substitute answer for all the examples. For a lot of it, it abstained from answer. It gave neither Italy nor Norway. So it's kind of, there's conflict between what it knew and then what's given in the inference documents. So it's getting confused. And it was like still giving the original answer for a few percent of examples. And then when we did the 50% swap, if the model is only looking at the document that it's given, it should give about half of the original answer and then half the time substitute answer. But it was giving the original answer about twice as much. So even when it's paying attention to the retrieved document, which it does, it's still using its parametric knowledge in a pretty subtle way. So it's kind of shows that it's important to actually update the model parameters themselves, even when we are doing this knowledge augmentation on the fly. And we have looked at we've been looking at this problem with the newer models on a more complex setting of long-form question answering, where the models are generating multiple sentences for complex questions. So before it was like kind of very simple question, and this is much more complex questions. And here we are like asking humans to annotate which sentences are can be grounded to the document that's given, and which sentences cannot be grounded to the document that's given. And we look at the proportion of sentences that the model generated that can be grounded to documents. And we saw that the model was still generating things that's not grounded in the documents, especially for GPT-3 and Alpaca. Those were happening. The Web GPT was trained with retrieval augmented, so it was actually doing a lot better here, but it was still generating something that's not in the documents too. So overall, looking at these results, we find that like augmenting language model with this kind of retrieved passages alone is somewhat limited, and we really have to inject the new information into the parameter space as well. So in the first part of the talk, I'm going to talk about how can we do this knowledge updating and propagation in the language models. And then in the second part of the talk, I'm going to talk a little bit different things about how can we update the models with user feedback. Okay. So the first part is a work that we published at ACL this year, and then another work that it's on the preprint. So there has been this work on this knowledge editing. It's an important problem. People have identified it as an important problem. So they were looking into, the language model being the Prime Minister of UK is Boris Johnson, and Rishi Sunak has been elected. So we would like to edit the language model's knowledge so that's now going to say Rishi Sunak instead of Boris Johnson. And they evaluate these approaches in two axes. One is whether for this question, whether the model we're going to give the updated answer. And then also for other questions, that's not this one, the model's prediction should not change. And these methods that they have proposed works pretty well on these particular examples. Like the model we can update the model parameters to make these edits. But what we really wanted to see is not just injecting a new fact and then let the model to be able to repeat what's been injected as is, but also make inferences based on the injected facts. So if someone became a prime minister in the UK, then Prime Minister of UK lives in 10 Downing Street. So this person will be now living in 10 Downing Street. And also this person will going to attend various international events as a UK representative. So we really wanted to study this kind of like after injecting one fact, can we see this kind of like model now can make inferences on it? There has been really no benchmark for studying these problems. So we started with relying on our prior work where we come up with entities that's having an origination date, meaning that when that entity has been invented or evolved. So here we are looking at one example, which is mRNA vaccine, which came in 2021. And we find these entities from Wikidata, and then we can look at Wikipedia to get their definitions. And then we take other sentences from Wikipedia, which has this entity in it. So the idea is if you understand or learn the definition of this entity, then you should be able to do fill in the blank, the close task of other sentences about this entity better than before you acquire the knowledge about this entity. So this benchmark was constructed automatically by scraping Wikipedia. And then we're going to evaluate on the perplexity, meaning the language model's ability to be predicting this target tokens in the input sentence. So that's the setting. We added this entity definitions. And then with that entity definition, we update the model parameters. And then we evaluate these probe sentences, seeing whether the probe sentence with the updated model parameter now gives a higher probability to the target continuation than previously. So how do we, what kind of methods we are going to look into about this editing or injecting entity definition? We start with something very simple, where we just prepend the entity definition. So we give the definition before the input, and then see whether that's going to make it easier to predict the masked tokens in the input sentence. This is the retrieval augmentation that I talked about before. No need to update the model parameters. It's super simple. But then at inference time, you are now encoding more tokens. It's more expensive. And here's the results. So when you first see the just input, the perplexity was about 31. But if you prepend the correct definition, the perplexity drops significantly. So perplexity, the lower the better. So if the model knows about the definition of the entity, then it can fill in the blank better. And also, if we give another definition of the another entity that's randomly chosen, then the perplexity is higher, much higher. So we can kind of see that adding the definition helps, but adding irrelevant definition hurts. I'm kind of sanity check that this was working well. But we really wanted to not just prepend it at inference time, but also wanted to update the model parameters to memorize this entity definition. So one very simplest baseline that we did was doing this continued pre-training, where let LM to memorize the definition sentence by doing continued pre-training on this entity sentences. And then we do evaluation on this input sentence. Okay. So this parameter updating now has issues with can potentially impact irrelevant examples because we're changing the model parameter that's going to be reused for all other things. But it has nice properties of can scale to integrate potentially larger amount of information because you don't have to prepend it at inference time. I always ask question whether do you think that this parameter updating which let the model to memorize these definitions would it work better than prepending, meaning the perplexity would be lower or higher than prepending definitions. And here's the result. So if you do this continued pre-training, this parameter update methods, the perplexity does drop compared to just showing the input. It's moved from 31 to 28.5, but it's still substantially worse than just prepending. So it's kind of like, the models now memorize this knowledge, but it's still in the it's like giant parameter space. And when it's trying to reason about this new entity, maybe it cannot locate and recall this facts that's inside the parametric knowledge very well compared to just prepending the correct definition in context. So we're like, how can we improve this better? So we introduced this context distillation, which has been used for some other tasks such as alignments and memorizing prompts. So here we are using it for knowledge updating. So if prepending the definition works really well, why don't we update the model so it's going to mimic the behavior of the prepended setting? So it's pretty simple methods. We have a teacher model and a student model. And the student model, we're going to only see the input sentence. And then the teacher model, we're going to also see the definition of the entity. And then we're going to update the student model's logits to mimic the behaviors of the teacher model's logits. Here, student model and teacher model could even be the same model, just it's in a different input setting. Okay. But this yellow sentence is our test sentence, so we cannot really do this on our test sentences. So we first have to generate what we call a transfer sentence where we're going to update the models. So how we do this is pretty simple. We start with an entity definition. I picked the definition of the Korean girl group students, and then let the language model to just keep generating sentences. And it generated sentences. I don't think these sentences are actually factually correct because it's new entities that the model actually doesn't know about. But the goal is about injecting this definition to the model. So it's not that important. And we let the model to mimic the behavior of the definition prepending setting with the distillation loss. So after we have done that, we can see the model performance is improved somewhat. So from 28.5 to 20, it dropped to up to 25.3, but it's still like worse than prepending the definition. So one thing that we also further tried is like, oh, what if we distill a random definition? Would it hurt model as much as it was hurting before? And we saw that it's actually kind of interesting. When you inject these random definitions, it still hurts the model. The perplex is higher than the default setting, but much less than compared to parameter, compared to this retrieval augmentation or prepending. So parameter updating is like augmenting the knowledge, but it doesn't work as well as prepending when it's the correct knowledge, and it doesn't hurt the model as much as the prepending. So it seems like there's like some pros and cons. I think there is like a lot of things that we can further look into. How can we augment the language model's knowledge with different methods? And this retrieval-based methods and then this parameter updating are both, I think, important pieces of the puzzle that we can further develop on. Before moving on to the second part, I will talk a little bit about the first part of augmenting LM with this retrieval augmentations, the simple methods that we have. I think the way that we are using this retrieval augmentation is still pretty rudimentary, and there's a lot of room for improvements. So one thing that we've been looking into is like, how can we introduce modules that can incorporate external data or external knowledge or other models to help this retrieval-based augmentations. It's kind of like similar to recent line of work where we are trying to augment the ability of language model with tools such as a calculator or compiler or translators and so forth. And here, like the focus that we are interested in particularly in is that after we do the retrieval of the document, the new knowledge, how can we integrate it into the model better? And we did the study on real-world fact-checking. Because like currently what we are trying to do is like trying to evaluate and augment the language model generated text. And as the language model generated text now resembles more and more like human generated text, maybe we should like, take inspirations from how we evaluate the human generated text. So that's what fact checkers do. So for example, in the sentence, Joe Biden said, when I was vice president, violent crime fell 15% in this country. The murder rate is up 26% the nation this year under Donald Trump. And what we can do, what the fact checkers would do is it's going to decompose the claim into multiple things that it has to check. So it says that the number 15% is correct and 26% is correct. And also like kind of look into the setting where this was made, like what kind of important things that it's missing. And then after that, we're going to do this Google search, find all the informations, and then the fact checkers, we're going to combine these kind of facets of information to generate this explainable judgments that can provide the label for the veracities. So this is the retrieval augmentation part. So in our recent preprint, we looked into doing these kind of things with language model. So it starts with the claim, and we first do the decompositions, And then with the composition, we can do the web search and then gather information. And then kind of further trimming down the information that we want, because the language model cannot really takes in like thousands, tens of thousands of tokens yet. And then we're going to further summarize this document and then let the model do the reasoning and then explaining to get to the final answer. So we have this retrieval augmentation, but we're introducing this like further modules such as claim decompositions and then summarizers to make this retrieval augmentation to language model more efficient and effective. Okay. So that ends the first part of the talk where I was talking about this knowledge updating and propagation in language models. I'm actually like a little bit split on before, like in 10 years ago or even 5 years ago, we were not like asking language models to do like contained knowledge. We were just asking whether you can understand the language that to the sentence, the document that we are given. But now we are like asking language models to do everything. Using its rich knowledges. And I think as we are moving to this kind of knowledge-rich task, we really have to be able to update the models with up-to-date, more relevant knowledges at inference times, and also update the model parameters knowledge. In the second part of the talk, I'm going to switch gears a little bit and talk about how can we continuously update the models with user feedback. So we're talking about this really large-scale language model that's really expensive to train, but once it's trained, it's going to get reused by a lot of people for various applications, right? And if you think about what kind of things were in the pre-training corpus, it's really mismatch of web information. It's like usually there are these newer models that's like trying to train on only high-quality factual stuff, but a lot of the best language models out there are like trained on this mismatch of information. And if you look at the pre-training corpus that it has consumed, there are some knowledge conflict, meaning that one document says A and the other document says B. And there are many reasons why this is happening. Sometimes it's just text written in different times, right? Like some news articles, we're going to say the last Winter Olympic was at Pyeongchang. Some document might say it was from Beijing because they're written at different times. And then if the model is memorizing these two things, then it might get confused. Oh, which one should I trust? And even more, there are a lot of like subjective things as well. Like, should animals have lawful rights? Some people were going to say animal should not have lawful rights. And then some might say that all living things should have basic rights. So these are kind of conflicting informations are what it's trained on. So maybe we should ask, when we are interacting with these models, models have this conflicting information, and we might have to ask the users like what they want out of these mismatch of what it has memorized. And what does it constitute a good answer for particular users or for particular applications? And another systems are actually in the real world these days a lot. Like trained models are deployed and interacting with the users in various settings like assistant, like Siri, Google search, and ChatGPT and so forth. And ChatGPT has like 100 million users, and it has a lot of plugins now so that you can interact with the users. So it really gives us a nice opportunity to like have the model to adapt and evolve and choose like which direction is right based on the interaction with the users. So that's what I'm going to talk about in the remaining time that I have today. And the idea is engaging users for learning question answering systems. So before we were training language question answering models with paired data of like, this is a question, this is an answer, and they collected many of them and then trained the model, right? But here what we are trying to do is instead of annotated data, we have the question that's posed by the user, answer provided by the model, and then the user give a feedback whether this is a good answer or a bad answer. And then from this interaction signals, the model we're going to learn a question answering model. So we had this paper, ACL last year, where we are doing this banded learning for question answering. We looked at kind of extractive question answering, but this is a more challenging learning setup. So we went back to kind of simpler question answering setup where we got given the documents to a model. User asks a question, model provides an answer as a span in the documents, and then we provide user feedback that's simulated from existing supervised data. So if like what the model predicted matches the annotation, then we say it's a good answer. If not, it's a bad answer. And then we update the model parameters from this feedback and examples with policy gradient. It's a kind of like a very, very simple form of reinforcement learning. But this was with supervised data. There was actually no interaction. We were just like simulating this interaction with existing supervised data. And today I'm going to talk about our follow-up work where we are actually deploying the question answering model and collect the real user / crowd workers feedbacks and then iteratively improve the models. This is somewhat relevant to recent work in learning from human preferences. So InstructGPT and these kind of models are now after you train the pre-trained language model, they further update the model to mimic the human's preferences. So we have the prompt, and then there are two samples from language model output. A user will gonna examine both of those outputs and then decide which one it likes better. And then the model will gonna update to increase the likelihood of generating the things that the model user preferred. So this is relevant to our study, but compared to these kind of work where the annotator is looking at multiple outputs, we are looking at interaction setup where the user is looking at a single output and then decide whether it's good or bad. There are some other work where they are trying to give a very detailed feedback. So the user gave some query, the model gave an answer, and then you can also provide a very detailed feedback about like, why the model answer is correct, incorrect, or correct. But this is a lot more expensive feedback. And when you are dealing with these systems day to day, you don't want to sit down and write like, why the model answer is correct or why the model answer is good. We just do a simple binary feedback where it's not binary. It's out of 3 classes, whether model answer is good or partially correct or incorrect. So that is our focus. We would like to pose minimal interaction overhead for users, and then we would like to do iterative developments, collect the data, train the model, and then collect the data again, and then train the model, and so forth. Yeah, so that's our recent preparing continuous learning extractive QA from human feedback. So interaction setting is pretty simple. User is prompted to ask a question about a particular topic. So it's about Winter Olympic medals, and then the model will gonna be given a passage that's relevant to it, and then we'll either generate the answer or say it's unanswerable. And then this will be fed back to the users, and then user will evaluate this and then say whether it's correct or partially correct or not. So we're going to start with the initial model that's trained with a small amount of supervised data. And then we're going to rotate its interaction phase and then a learning phase. So in the interaction phase, the user asks a question, model make predictions, and then user we're going to say it's good or partially good or bad. And then you are going to update the model with the same reinforcement learning objective. Policy gradients, and then update the model parameters so that the model is better. And then we're going to deploy this updated model again, and then collect more interaction data, and then update the model again, collect the more interaction data, and then update the model again, and so forth. And we did it for about like 9 rounds of iterations. So you can kind of see that models is evolving, and then users interaction data is also changing on different distributions, because model that we are using at the first round of interaction and then the last round of interaction is not the same model. And here are the results. So we run it for 9 rounds, and then we are looking at the user feedback. At the beginning, the users were saying only about 50% of the questions were answered correctly. But at the end of the interaction, we can see that about like 70% of questions were able to be answered correctly. And you can also see the results on supervised, not supervised, separate evaluation data sets of various sorts. And we can also see that the performance on this evaluation data set was also steadily improving over the course of this interaction and banded learning. So this kind of shows that like learning from user interactions is a promising direction for actually adapting and improving the deployed language models, the question answering models over time. In this study, we were looking at a pretty simple setup of extractive question answering model, where we are giving the question and the passage where the answer should come from to the extractive QA model. And it was like either highlighting the span in the passage or saying it's unanswerable. But this is like a very unrealistic setting. Typically, we don't have these passages where you can answer the questions. And the model is going to be only given the question and look up the documents and use its parametric knowledge and then to generate the answers, right? So doing this kind of interaction study on this like a lot more challenging setup is something that would be exciting to look at. Okay, to summarize the second part, I've been talking about learning from this simple banded user feedback for extractive question answering. These kind of studies are a lot harder to do than doing something with fixed models, because you actually have to build a model and then deploy it and then let users interact with it and then train the models. But I think this is also very exciting directions because there are so much potential for this kind of user feedback and interactions as the models are actually getting deployed. There are a lot of open questions, like how the more users will going to adapt as they interact more and more with the users. You know, when you first type something on the Google search query and then how you search Google search engine these days, like your behavior adapts to the models, right? So looking at those kind of behaviors would be pretty exciting. Here we are looking at a pretty simple reward functions that we manually designed, but we can also further look into learning a reward model or designing a better reward functions. And if there's like a noise in the user feedback, how will that impact the learnings and stuff? So those are also good things that we can further study. It's like really now a dynamics between the word and then the users and then the model that's interacting with them. Okay. Yeah, so I think that's actually most of what I wanted to cover. In the first part of the talk, I'm going to talk about how can we update and propagate new knowledge, inject and propagate new knowledge into the language models. There's 2 different paths of injecting knowledge: retrieval augmentations or parameter updates. And then in the second part, I was talking about how can we update these QA models by eliciting feedback from the users. Yeah, I think that's all actually I wanted to cover today. I think I went a little bit fast, but so I guess we have ample time for question answerings. I would like to thank my co-authors and happy to take more questions.
랭귀지 모델 활용에 대해서 어떻게 업데이트할 건가에 대한 말씀을 해주셨는데요. 질문 있으시면 채팅창에 올려놔 주시기 바랍니다. 두 가지 질문이 현재 올라와 있는데요. 첫 번째, 39페이지 결과에 대해서 어떤 데피니션을 주느냐, 아마 입력을 주느냐라는 말씀인 것 같아요. 따라서 성능 차이가 달라질 것 같은데 다양한 데피니션에 대해서 한번 성능이 어떻게 달라질까요? 뭐 여러 데피니션을 사용해서 한번 성능 평가 같은 걸 해 보셨나요? 어떻게 될까요?
네. 여기서는 사실 그냥 definition을 그냥 first sentence in Wikipedia로 했거든요. 그래서 사실 여기서는 네, 좋은 질문이고 당연히 어떤 definition은 얼마나 많은 양의 information을 inject 하느냐에 따라서 또 performance difference가 있을 것 같아요. 근데 여기서 보고 싶었던 거는 똑같은 information을 inject 했을 때 이렇게 다른 augmentation 메소드가 어떤 다른 결과를 가져오느냐가 주 연구 주제였기 때문에 definition은 fix한 상태로 메소드를 vary 했는데 메소드를 fix하고 definition을 vary 하는 것도 충분히 재밌는 주제가 될 수 있을 것 같아요.
네. 네, 감사합니다. 두 번째 질문인데요. Learning with user feedback은 흥미로운데 파인 튜닝과 비교할 수 있을까요? 코스트나 성능 측면에서. 글쎄 한번 모르겠어요. 직접적인 비교가 가능할지 모르겠는데 혹시 뭐 물론 사용하는 데이터도 다르기 때문에 그 파인 튜닝과 그 말씀해주신 유저 피드백을 이용한 러닝이 비교를 한다면 어떻게 우리가 비교할 수 있을까요?
어, 네, 사실 learning from user interaction도 어떻게 보면 fine tuning이라고 볼 수 있는 것 같아요. fine tuning 그러니까 pre-training이 있고 fine tuning이 있으니까 이것도 어떻게 보면 일종의 이미 pre-trained 된 모델을 더 fine tune 업데이트 하는 건데 다른 점은 보통 fine tuning 데이터는 이렇게 bandit 데이터가 아니라 피드백 데이터가 아니라 annotated question answer 페어거든요. 그래서 example 하나하나를 보았을 때는 훨씬 information 양이 많죠. 왜냐면 예를 들어서 이게 좋은 앤서라고 했을 때는 상관이 없지만 나쁜 앤서였을 때는 뭐 그 example에서 어떤 게 좋은 앤서인지 bandit example에서는 알 수 있는 게 아니니까 그 만약에 똑같은 양의 데이터가 있다면 bandit 데이터보다는 supervised 트레이닝 데이터가 더 좋은 성능을 주는 게 어떻게 보면 당연하고 그게 일반적인데 이런 슈퍼바이즈 데이터는 애노테이터가 애노테이트를 해야 되고 이런 인터랙션 데이터는 그냥 디플로이한 상태에서 내추럴리 얻을 수 있는 데이터라서 훨씬 쉽게 얻을 수 있다는 게 장점이죠.
네, 감사드립니다. 또 뭐 추가 질문 있으시면은 이제 계속 올려놔 주시고요. 지금 우리 예정된 시간이 거의 되긴 했네요. 그래서 최은솔 교수님 혹시 뭐 질문 더 있으신가요? 지금 질문 있으신 분들은 이 귀한 마지막 기회입니다. 지금 활용해 주시고요. 네, 질문이 갑자기 마지막 기회라고 하니 많이 올라오시네요. 교수님 하시는 연구가 유저 데이터를 수집하는 일을 많이 하셔서 문의드립니다. 최근 크라우드 소싱에서 워커들도 챗 GPT를 사용하기 때문에 신뢰하기 어려워졌다는 의견들이 있는데 이런 상황에서 신뢰할 수 있는 데이터를 얻을 수 있는 방법이 있을까요? 라는 질문을 해주셨네요. 네, 혹시 최 교수님 네, 의견 한번 부탁드리겠습니다. 굉장히 핫 이슈가 될 것 같은데요.
네. 근데 이게 사실 좀 되게 재밌는 질문인 것 같아요. 이게 옛날에는 처음 스쿼드 나왔을 때랑 뭐 이미지넷 이런 거 했을 때 진짜 쉬운 태스크를 많은 사람들이 쉽게 할 수 있는 그런 large scale 데이터를 컬렉트 하는 거에 되게 포커스를 많이 맞췄었고 그런 데이터를 통해서 AI가 되게 많이 발전했었는데 이제는 그런 게 아니라 그냥 unsupervised 데이터를 많이 모델이 메모라이즈 하게 하고 그런 large scale 데이터를 컬렉트하는 거에 대한 임포턴스는 좀 많이 줄어든 것 같아요. 그래서 점점 포커스는 어떻게 작은 어마운트 데이터라도 어떻게 좀 하이 퀄리티 데이터를 구할 수 있냐 이런 건데, 그래서 점점 좀 일반적인 크라우드소싱 웹사이트보다 좀 이렇게 퀄리피케이션을 해서 인터뷰를 해서 조금 더 그 도메인 엑스퍼트를 하이어한다거나 하는 식으로 데이터를 콜렉트 하게 되는 것 같아요. 그 뭐 딱히 그렇게 엄청 쉬운 방법이 있는 건 아니지만, 네, 좀 이렇게 다른 플랫폼과 좀, 좋은 그런 데이터를 구할 수 있는 사람을 찾아서 그 사람을 좀 더 길게 고용하는 그런 식으로 데이터 컬렉션의 양상이 변해가고 있는 것 같아요.
네. 뭐 요새 이제 자연어 처리 모델이 인간을 대체할 수 있을 것 같은 분위기가 되다 보니까 얼마나 신뢰할 수 있을까 뭐 그런 관심들이 있고 또 연구도 많이 진행되는 것 같습니다. 그다음 또 질문이 있는데요. Retrieval augmented 관련해서 질문이 있습니다. 사전 학습에서부터 근거로부터 답을 찾는 혹은 비관련 근거는 참고하지 않는 사전 학습 데이터를 많이 넣어주면 prepended retrieval augmented 성능이 개선될 여지가 있을까요? 라는 질문을
네,
해주셨네요. 네.
네, 사실 가장 크게 large-scale 모델들, 뭐 라마나 GPT 같은 경우는 이렇게 리트리버를 안 한 상태에서 트레인을 한 경우가 많은데, 아까 보여드렸던 스터디처럼 웹 GPT처럼 이렇게 리트리버이 들어간 상태로 트레인한 모델인 경우에는 좀 더 페이스풀하게 앤서하는 경향이 있어서 리트리버 어그먼티드 하는 걸 프리트레이닝에 하는 거 되게 좋은 디렉션이라고 생각해요. 근데 프리트레이닝 스터디는 워낙 아카데미아에서 라이지 스케일로 하기는 어려워서 좀 그런 단점이 있긴 해요. 네, 어려움이 있긴 해요. 네.
네, 네, 감사합니다. 그리고 또 질문인데 사용자의 피드백 퀄리티에 따라 리워드 점수를 다르게 해주는 방법은 아직 연구가 더 필요한 부분인가요? 라는 재밌는 아이디어 주셨네요. 네.
음, 네, 그 사용자의 피드백의 퀄리티를 이스티메이트 하는 게 쉬운 문제가 아니라서, 근데 이렇게 되게 노이즈한 피드백을, 저희가 그 전 스터디를 했을 때 피드백이 정말 막 엄청 노이즈가 심하면 모델이 러닝을 페일하는 걸 많이 봤거든요. 그래서, 노이즈 퀄리티를, 필터링을 잘 하는 방법도, 중요한 연구 과제인 것 같아요.
네. 말씀대로 사용자의 피드백을 이벨리에이트 하는 게 쉬운 문제는 아닌 것 같습니다. 네, 질문이 더 뭐 질문 또 입력하시는 동안에 제가 좀 최 교수님께 좀 여쭙고 싶은 거는 지금 굉장히 흥미로운 연구들, 라지 랭귀지 모델 관련한 연구들 많이 하고 계신데요. 여기 듣고 있는 학생들을 위해서 이 라지 랭귀지 모델의 뭐 최신 연구 동향이라고 해야 될까요? 뭐 앞으로 이런 쪽의 연구들 혹은 현재 이런 쪽의 연구들이 많이 진행되고 있다. 뭐 그런 최신 연구 동향을 조금 간단히 한번 소개 부탁드리겠습니다.
네. 사실 뭐 저라고 되게 분야가 요새 되게 많이 커져가지고, 근데 제가 많이 관심 가지고 있는 분야들은 이렇게 retrieval augmented setting 사람들이 많이 또 보는 것 같고, 그 제가 아까 간단히 언급드렸던 tool former처럼 이렇게 large language 모델이 뭐 multiplication 잘하는 건 아니거든요. 그래서 이렇게 large language 모델이 못하는 거를 이렇게 다른 이렇게 모듈을 이렇게 어그먼트 해서 이렇게 다양한 툴을 쓸 수 있게 하는 것도 사람들이 많이 보는 것 같고, 근데 그거 좀 인더스트리 스타트업에서 더 많이 보는 것 같긴 하지만 그런 쪽도 있고, 다른 한 분야는 제가 많이 하진 않지만, 리즈닝 분야도 되게 익사이팅한 것 같아요. 그러니까 예를 들어서 지금 제가 보여드렸던 많은 이그샘플은 앤서가 그 인포메이션이 retrieve 다큐멘트에 있는 경우인데 그게 아니라 이렇게 다큐멘트에 이런 스니펫들이 있고 그걸 어떻게 컴바인해서 리즈닝을 하고 멀티 다큐멘트에 스프레드에 있는 인포메이션을 gather하고 그걸 통해서 더 이상 어떻게 그 깊이 있는 추론을 할 수 있게 하는 거 그런 점도 많이 보고 있는 것 같고요. 또 efficient한 모델 만드는 것도 여전히 계속 중요한 토픽인 것 같아요.
네, 감사드립니다. 뭐 요새는 랭귀지 모델이 워낙 발전이 빨라서 뭐 이제 저기 구글 바든가요? 또 이제 뭐 이미지를 넣어서 뭐 멀티모달로 이제 검색하고 해서 점점 가까워지고 있는 것 같습니다. 그래서 우리 인공지능 쪽에 연구할 토픽들이 많은 것 같고 또 혹시 랭귀지 모델 연구 주제 아닌 사람들도 상식 차원에서 알고 있어야 되지 않을까, 어떤 기법들이 있는지 어떤 문제들이 있는지 뭐 그런 시대가 돼가는 것 같습니다. 오늘 관련해서 그 최신 연구에 대해서 소개해 주신 최은솔 교수님께 감사 말씀드리고요. 또 지금 온라인으로 뵀지만 또 나중에 한번 대면으로 뵙는 시간을 가졌으면 하는데 네, 질문이 하나 막 올라왔습니다. 검색 증강 언어 모델의 경우 검색 모델의 성능에 크게 영향을 받을 수밖에 없을 것 같은데 언어 모델에서 이런 문제를 완화할 수 있는 방법이 있을까요? 라는 질문 주셨네요.
네, 되게 좋은 질문이에요. 그래서 사실 제가 액티브리 하고 있는 연구 주제 중에 하나인데, 그 약간 그 검색에서 나오는 그 인포메이션이 relevant 하지 않을 때, 그거를 selectively, 좋은 정보가 있을 때만 쓰고, 없을 때는 다시, 검색을 다시 한다거나, 이런 식으로 해서 업그레이드를 해야, 그 약간 툴포머 아까 얘기했듯이 그렇게 이렇게 검색 툴을 더 잘 쓸 수 있게 하는 연구는 계속 진행되고 있는 것 같아요. 네.
네, 감사드립니다. 이제 시간이 거진 다 돼가지고요. 네, 이번 세션 인바이트 톡 세션을 마치도록 하겠습니다. 다시 한번 최은솔 교수님께 감사드리고요. 또 다음에 한번 대면으로 뵐 수 있는 기회 있으면 좋겠습니다. 네, 감사합니다.
초대해 주셔서 감사합니다.